We're getting a little bit of
It makes a cage that is forced to stay inside.
Oh, there we go. Yeah. So we are generating counts. We have fusion. Yeah, so you'll see that it comes down to a very, very sharp focus there in the center. Almost one little point with two beams going in the center. That's a very nice little star. Very cute. So we're running at about 25,000 volts at it's fluctuating somewhere around 1.5 milliamps input power. I can do this, and basically what I'm doing there is letting more current in. Oh, counts that. And when it does that, you should get a spike. That looks really bright. And what you'll see here is the grid starts heating up very fast. And essentially when this happens, we're probably getting a heck of a lot more X-rays than we were when the grid was cool. Why this is let's say we have a filament in a vacuum, like a light bulb. Once that filament starts heating up, it starts to undergo a process called thermionic emission, and that's basically the process of electrons evaporating off of the metal itself. And so those electrons usually, are fine in the light bulb sort of environment, but in this environment where you're trying to get specific particles to be able to contact each other, any sort of particle from the outside can be counterproductive to that. So if you look at it as two objects coming together, if you've got objects flowing past them, then the chances of those two particles interacting with each other is dramatically lessened.
What's the purpose of liquid nitrogen again?
Okay, so basically I have an electrolysis unit right here. And essentially what that is flowing a current through heavy water. And in doing so, I split the heavy water into deuterium and oxygen. The oxygen is just vented out the top. The deuterium goes up through this line. The problem is the deuterium carries a little bit of moisture with it, so the liquid nitrogen is used to freeze that moisture off before it gets back into the chamber.
Okay, I hate to sound like